Hi everyone, in this video we are going to discuss isotopes. So isotopes have a very, very specific definition, so make sure you pay attention here for the next minute. Alright, so isotopes simply are when you have two or more forms of the same element that differ in mass. Okay, so that seems kind of complicated, but there's two very, very important pieces of information that we need to pull out here. So if we are talking about the same element, by definition, that means that these species or these forms of things that we're talking about have the exact same number of protons. Okay? If they're the same element, by definition, they have to have the same number of protons. It is not possible to have the same element with a different number of protons. That's just not possible. But now, if they differ in mass, what that means is that these elements have a different number of neutrons. Okay, so their proton count is the same, but their neutron count is very different. So let's dive into this and talk about it in terms of an example, because I think that will just help clarify it a little bit. So let's start off by just looking at hydrogen. So we have hydrogen, and hydrogen actually has two very, very common isotopes. So one of them is called deuterium, and the other one is called tritium. Okay, so let's make a little chart. First thing I want to chart out or plot out are the number of protons. Then I want to look at the number of neutrons. And then I want to do something totally fancy, and I'm going to add the number of protons to the number of neutrons. So what I initially told you is that all three of these are the exact same element, but they're different isotopes. So by definition, that means that all of these have to have the exact same number of protons. So we know hydrogen has an atomic number of 1, which means it has 1 proton, which means deuterium has to have 1 proton, and tritium has to have 1 proton. Now, the number of neutrons, I don't expect you to know that part yet, but by the end of the video, I would absolutely expect you to be able to have figured this part out. So I'm just going to tell you that hydrogen has 0, deuterium has 1, and tritium has 2 neutrons. So now, what we're going to do is add the protons to the neutrons. So hydrogen has 1 plus 0, so that would be 1. Deuterium has 1 plus 1, which gives us 2. And tritium has 1 plus 2, which gives us 3. Now, this chart right here, this section that we just created, the protons plus the neutrons, actually has a very specific name. This part right here is called the mass number. And the mass number is simply the combination of protons plus neutrons. So to determine the mass number, you literally go protons plus neutrons. Simple, okay? Very, very simple. So let's just check in, see if we understand what a mass number is. So I'm going to give you an example. We're going to talk about carbon-14, and I don't expect you to know what that means yet, so I'm going to tell you that it has 6 protons and it has 8 neutrons, okay? So given this information, what is the mass number? Again, we're talking of carbon-14. All right, did we get an answer? Hopefully we did. And so what we have to do to determine a mass number is you simply add up your protons plus your neutrons. So for carbon-14, we said they have 6 protons, and we said it has 8 neutrons. 6 plus 8 gives us 14. Ding, 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 carbon-14. 14 is definitely the answer. So to determine the mass number for carbon-14, it would be 14. Now, how do we represent this in a very simplistic way? We have chemical formulas, we have mass number, we have atomic number. We need a very simple way to represent that piece of information that we could then pass on to a coworker or a colleague to transfer this information. So what we have is what's called an atomic symbol. So we have our Z, we have A, and we have B. So Z is the easiest one. We've already mastered that. That is your element, okay? So for our example here of carbon-14, it would just be a big C. So carbon is represented by C. That's your element. Now A, this one hopefully we can already do. That one is actually your atomic number. So your atomic number, which really we already know means the number of protons, Okay, so if we were to look at a periodic table for carbon, we would see that it has an atomic number of 6. So it always has 6 protons. So where that little a is over here, we just now write 6 on our example on this side. Now the last thing we need to look at is B. B is represented by your mass number. So mass number is what we just talked about, and so mass number is the combination of your protons plus your neutrons. So for our example here, we just determined that our mass number is 14, so our symbol would actually be a 14 right there. So if we were to write this in shorthand notation, this is what carbon 14 would look like. So right away you could tell me the element is carbon. You could define that. If I didn't tell you this part right here, you could have figured that out because you know the atomic number is 6, which means 6 protons. You could have gone to the periodic table, found the 6, saw that it was carbon, and come up with C. And then you know, because I told you that we're talking about carbon 14, that we have 6 protons and 8 neutrons, so this number had to be 14. Hopefully that makes sense, but we're going to work through 2 examples just in case that's not perfectly clear. So given this symbol right here, we're going to do U235 with a little 92. Here is my question. How many protons are in U235? Go. Did you get an answer? Hopefully this was super easy, but just in case it wasn't, when we're asking for the number of protons, all you have to do is look down here to this bottom piece because we're looking for your atomic number, which again just tells you how many protons you have. So right away, hopefully you looked at this, saw the number 92, and typed it in as fast as you possibly can because 92 is the correct answer. So good job if you got that correct. Now, I'm going to push you. Instead of asking protons, now I want to know how many neutrons are in U235. Go. Did we get an answer on this one? This one was a little bit more complicated, so if you didn't get it, don't worry about it. We're going to go through it together. And so just to figure this out, all we had to do was remember the definition of a mass number. So mass number is just equal to your number of protons plus your number of neutrons. So now the mass number was given to you. We said we're talking about U235. So for our little equation here, we have 235, which is equal to number of protons. That was our previous question. We came up with the answer 92. So 92 goes here, plus, and I'm just going to use an algebraic x to represent our number of neutrons. All you had to do was go 235 minus 92, and if you are super brilliant, you could do that in your head. If not, a calculator would suffice, and you would come up with the number 143, which is the correct answer. Hopefully that makes sense. Again, I know I say this every single time, but if it doesn't, please stop. Ask a teacher, ask a TA, ask me, come to office hours, come chat with me. Let's figure this out. Let's get this down so that we can move on to the really cool stuff. Have a great week. Take care of yourself and drink water.